Sorry, it took a bit, didn't get internet, but yeah, we could start today's lesson. We're gonna talk today about how to make maps, and first we're gonna revisit how to make static maps and maybe pimp it a bit still from where we already were. And then we're also gonna make some interactive maps where you can zoom and pan and click on things and show values. Yeah, let's just start as always with the in our notebooks. So in the CSC notebooks environment, in the notebooks directory lessons and lesson 5, there's 2 files this time, so we have a bit less material today, so maybe we do finish on time for a change. There's this static maps file, and we're going to start with this one. And I hope everybody can see everything, but it looks good, I guess. So up here, there's also links to the lessons 3 and 4 and 2 also, and then a link to Matplotlib's documentation. So remember those. I'm gonna open them. Okay, those links don't work. All right, but they work over here. So in lesson 2, we first plotted, or actually in this map projections part, we first plotted maps really like that, next to each other or projected into different coordinate reference systems. Then we also, in the lesson 3, we then plotted maps that we had joined from different parts. So we had this population density around points, and we also plotted this entire population density data set in a map. We already used a legend here also. And then in lesson 4, so last week, in the reclassifying data, I wasn't there for that, but I hope you did do these plots with different reclassified categorized data, like those. And we're going to put all of that together in this lesson again to make a really fancy multi-layer static thematic map. Let's start with these data input, data loading cells that are already pre-filled here, because then we don't have to type so much. So we're going to use again this Helsinki region travel times to the railway station dataset. And then I also added here 2 layers from the Helsinki CD WFS endpoint. So that's for one, the metro lines. So like they're both part of this Seutukartta, and liikenne, so traffic, and then the metro line. And the other one are the main roads, so Päätiet. And we're going to use them to create a nicer map. And before we go anywhere, oh yeah, there's again this problem exactly. I forgot about this. So we have to then restart. Like I'm gonna add here Laura's workaround, because that works so well. Or it doesn't work for everybody, but it did work for me all the time. So if we, before importing GeoPandas, have this input OS, and then was it the sys.path? But I'm maybe quickly checking from what Laura had posted. And Slack had signed me out, okay. And that was in week 3, I think, when that happened. So yes. Oh yeah, we want to set the environment variables actually. So it was always environ, and then the path to the proelib. So because otherwise somehow on the notebooks this doesn't work. So, and we want to set that to this opt conda share approach. Yes, that one. So, and I think I have to restart the kernel before, like restart the notebook before doing that. So once that has restarted, I'm running those 3, and then hopefully this error message doesn't come this time. Yes, and it seems to have worked. Did everybody, I can scroll up here again, so like this one is important to work around this conda problem of this projection PROI4 library not being installed. Is it large enough? Is it readable? Yes, okay. And you can still maybe increase it a bit. No. Hey. And once that worked, and I can copy that into Slack maybe again as a reminder in the week 5 folder. So once that worked, and once we have these 3 data sets imported, so there's the accessibility grid, there's the metro, and there's roads. Let's maybe quickly show them also. So accessibility grid is this, like, remember this travel time to the railway station with like a car or with public transport. That was this column here. So from this place somewhere, this grid cell somewhere in Helsinki metro region, it takes 108 minutes to travel to a railway station, but only 48 by car. And we have used this data set before, so nothing new. And then metro on the other side is a data set that has a couple of line strings, so the different metro lines that we have in Helsinki. So the whole western metro part, but then also these parts that go to from kind of, I think, from Ottaniemi onwards until Vuosaari, or to then from Itäkeskus to Mellonmäki. And finally, we also have this roads data set, and that one is a lot of different line strings. So there's interesting enough to know, there's names for some of them. So Mäkilininkato, Länsimaantie, Lahdenväylä. And maybe remember, like, one of the main thing was, if you just use this GeoPandas plot, you have to make sure that all the data is in the same reference system, because it doesn't really care about it. So it just plots it, whatever reference system it is. So let's start by checking that. So we can just use this assert statement again and say that we want to make sure that the accessibility grid CRS is the same as the metro CRS is the same as roads CRS. I don't know whether we've done it before, but you see here that like this comparison, or this Boolean comparison, binary comparison operators can just be chained. So if you want to have all 3 the same, then you can just say equals equals. And actually it's not. So some of them are different, it seems. So let's see what they are. Oh yeah, how I type so fast here is using the tabulator key. If you, I don't know whether I've ever shown you the trick. It's very common on all kind of Linux and Unix systems. If you if you want to complete something that you have typed, or it's also in many programming environments, you can use this tab key. That's the one on top of the caps lock, so underneath escape somewhere there. So this the one that has two arrows that point in different directions. So if you type part of, for example, a variable in here, and then press that tab key, then it would complete everything else. If there's now like something that's ambiguous because there's multiple options, for example, if I now add this dot here and I know I want to have the CRS, but maybe I don't know, then I can press it twice or no. Okay, there it is, just took a while. And it would offer me different options, except now. No, it doesn't anymore. Okay, spoke too quick. So I have to know something. It should work. Maybe it works for you. Maybe it's also because I zoomed in so much, so there's not enough space to show things on the screen. But anyway, we wanted to check what is the reference system of the accessibility grid. So that's this EPSG 3067, which is the newer Finnish UTM-based reference system. And then let's check the metro. That's a different one, 3879, so the older Finnish Gauss-Krüger system for also like this southern centered Finland. And then finally roads, that also has this Gauss-Krüger system. So since this UTM system is more, or this newer Finnish system is more universal, let's project the other two into that one. And the easiest way to transform that would be to just say road should be road but converted, so to a CRS, and then we can just add here as the input the accessibility grid CRS, so we definitely have the same thing. And I'm gonna copy and paste that line and then just change metro twice over here. And it's actually called roads, not road. And then I can run this assert statement another time from up there, so I can All right. Did everybody arrive here? And do we have, everybody has 3 different data sets that have the same common coordinate reference system? Great. Then there's a task which you should do by yourselves, which is plot a multi-layer map. And that's also why I opened these different former lessons up here, because they all have a bit that you might have to remember. So maybe as a bit of instructions to add multiple layers to one plot or to additional layers, you want to keep the return value of the first plot, which is this axis AX, and then pass that into the additional printed layers. So where did we use that the last time? So like we used that here, for example, for setting the axis title. So like but we did use that more than that also. Or was that in the homework, maybe? Was that in the hints for homework? No. But we've definitely done that, so I hope you remember this. Was that already earlier, maybe? No. I know. We did that, for example, here in lesson 3 when we plotted multiple things into the same map of which points are in which district. So like we took this AX thing like as the return value of the first plot function, and then added it to the additional plot functions. And maybe I should zoom in here too. So it's also covered in lesson 7 of GeoPython apparently. But back to the task now. So the idea is that you first plot the accessibility grid and use a quantiles classification scheme. So that's what we covered last week, or what Howard showed you last week. And then on top of that, add the roads network and the metro lines in maybe different colors, different thickness, play around a bit. There's a few tips down here then still after these instructions. So you can change the classification scheme using this scheme parameter. So that's from last week. Change the color map using this CMap parameter that also has been covered already in GeoPython, but we've revisited a few times. Then something new is this, like you can also supply this alpha parameter, which controls the transparency. So that's a floating, like a decimal number between 0 and 1, and 0 is complete see-through, transparent. 1 is completely opaque. So if you have 0.5, it's half see-through. And for the lines, it's also the color parameter that sets the lines, and the line width can set the lines. And then there's still like one extra tip, which is kind of the last thing to do once you've done all the others, which is that the road layer is much larger. So it covers almost all of Uzima, of the entire province. So all the other layers would be really shrunk into the center of the map. So I'm gonna check the time, and maybe let's say you have 10 minutes to do all of this. If you finished earlier, to do something else if you want, or pimp the map further. And you can also do all of this step by step and have multiple code cells and everything. So I'm gonna slowly again start to do the same thing. So I'm gonna start with the most complicated one, plotting the accessibility grid and adding a scheme there, choosing a column from which it is taken the data, choosing a color map, setting the line width to nothing, to 0, so we don't have lines, and adding also like this new alpha parameter, so we have 80% transparency, or opposite 20% transparency. And then I still also added like this figure size to make it a bit bigger. And if I just plot this one alone, it already takes a while, then I get this accessibility to the railway station using public transport, that is. But if I want to add additional layers, I have to remember this, the return value, and then pass it to the next one. So I would, for example, next plot the metro. No. And if I add that one too, then I also have the metro here. I don't really like the metro in blue, maybe, so let's make it, say, orange, like the real Helsinki metro. And then I have the metro line on top of here. Is this already all the way? Yeah. It's Martinkulle somewhere here, where it used to go, so this is already the entire one.
Could you quickly explain again why you have AX equals AX?
Yeah, that is, yes. If you want to, so like all of these plot functions return the plot object, which, because this is matplotlib, it's called an axis, and that's why we choose AX as the name for it, and also the parameter is called AX. But what it is actually like this, like some kind of object that contains the plot, which is also then displayed. So if I want to add something new to the same plot, I can reuse this object, and which means like I can also reuse it in a different cell even. I think I'm not 100% sure, but let's try adding, like taking this to the next cell and adding here still like doing the same for the roads, and see whether that actually makes a difference. No, it does not work apparently. So once it's plotted, once it's shown once, then apparently it's used up. So I bet you can just call here like some AX show or display or something, but no. But anyway, like it's not the figure, the entire figure. It's kind of the drawing area. So this AX, so it's a bit of complicated terminology in matplotlib, but what you need to know is it's kind of the container where the plots go into. So let's add here still the third, the roads, and I choose maybe gray because roads are gray. And then what happens is that, yeah, this data set is much larger. So it goes all the way to, I don't know, here's SIPO somewhere. I don't know where it ends here, but anyway, it goes a lot outside here. So let's maybe cut it a bit smaller. And the way we could do that is exactly how we did that also in GeoPython lesson 7. What is it? Maybe in here. So there was somewhere set x lim and set y lim. No, so it was in a different part of lesson 7. Okay, it's somewhere in here. I promise, but we can just use again on this axis object, whatever it is, we can use this set the limits on the x-axis and set the limits on the y-axis. But because we don't know what that is, and it can be just coordinates, so we now see here, for example, like the west-east coordinates are here in the 300,000s around Helsinki. So we want to maybe cut it here and cut it there, and then the ones going south-north are in the 6,700,000 range. So that's meters from the equator in that case. So we want to cut it here or somewhere there, but I don't want to guess those. So let's get the like we can do that separately here. Let's get maybe the bounding box of this accessibility grid, and that's total bounds of a geodata frame. Shows me that like the minimum x value is this one, the maximum x value is this one. So like in this 300,000 range, and then in the 6,600,000 range for the south north, and we can just extract that here on the spot and assign it to variables. So this is the minimum x, the minimum y, and then the maximum x and the maximum y is this, and then we have those values, and we can use them down here to set the range of the plot. No, but we want to set it in both directions. No, also on the y-axis, and then it's zoomed into exactly that layer. And I have to zoom it out here, otherwise you don't see the full plot. So maybe I should make it a bit smaller here. And I still wanted to maybe make the lines of the roads a bit thinner, because there's so many of them that it's really hard to see. So we have a multi-layer map, and so it was not so difficult, but it was also putting together parts that we learned in very different lessons. So yeah, it's kind of, everything is a bit coming together now towards the end of the course. That's also going to be a theme of the homework you're going to see. But let's do something else that we have done earlier. Let's add a legend. So and the best part is you can just copy and paste all of this above here, and just add here like the parameter that's legend equals true. That's again something we've done before. And then we have a legend in the corner that shows us how the classes work, except that this is the wrong order of things. Sorry, I'm taking away the scheme here still. So we just print the values. So everything I did was now just delete the classification scheme, because then the legend looks like completely different, just to show you. So it's just this color gradient then, and this is not very good cartography if you maybe remember from, I don't know, some bachelor introduction to GIS or cartography. So this is a continuous range, but then it goes over all the colors of the rainbow, so it's really hard to read, or it's not very intuitive which way it goes. So maybe I can tell you that this site here is actually like a matplotlib color bar, and there's a link down here you can also open. So it accepts a lot of parameters, and you can move it, for example, to a different place or make it vertical, horizontal. But also we want to change the color scheme here. And I don't know, we could make here, for example, yellow to red, if that's available. No, it's not. But I added here also like some, here's a list of color schemes. Let's just use the reds only. Stay within one color. But actually, why I opened this one here and being confusing already, let's try to put it somewhere else, the color bar. So it accepts these, or let's try to add a label, like a title for the color bar, and it accepts for the legend. So it accepts all of these keywords to create it, and among them there's label, which is how to add the title to it, and all of these arguments we see over here in this documentation for the color bar can be used inside the plot if they're passed to a dictionary called legend keywords, and I'm going to copy it from there. and edit here underneath the legend thing. And I already said it's a dictionary, so we can just, like, it should be a dictionary. And we can just add here all of these parameters from over here. And this is a typical, I know this is now a bit confusing and maybe a bit frustrating, but this is a typical task in these Python packages that take functionality from here and put it into another library. That really often you have to figure out that, oh, this legend is in fact a color bar, so which parameters can I pass to it? And then look into the original documentation on the other end. So in this case, I wanted to add a title, so I scrolled down here and saw there's one parameter that's called a label, and it's a label that's being printed somewhere. So I can here now add, and it has to be a string because it's a dictionary. So if I say here now, like, that was the travel time in minutes. So what we changed here is now we requested the legend and we added some keywords of how this legend is supposed to come. And I'm running this in the meantime while you can copy what I just typed. And then it has a label here. So that's just to add a bit of context. There is many more parameters that can be passed here. So can anybody figure out how to put it instead underneath the map and horizontal? And I have already scrolled to the right place, so you just have to kind of read my screen and then type it in your notebook. So the only thing we actually need is add here like another parameter that's called location, and it was bottom. And then the bar would be underneath here. So I just adding another keyword that's being passed to this color bar. Now, if we go back and again take the original code from up here, which does have the scheme, so does have classified categorized data, and also add a legend here. No. Then this legend looks a bit different, and it's also completely different. So it looks a bit different, but it actually is a completely different object. So it's not this color bar anymore that we opened here, but instead it's a legend. So it's just a different type of matplotlib object. And what comes with it is that matplotlib, I don't know how old it is, but it feels like it's 30 or 40 years old software, which means many of the things are not very logical. For example, if we would now want to add like a title to this legend, and I would copy the code we used up here, like the same legend keywords. I can tell you already this is not going to work. or I would be very surprised if it works, but no, it doesn't work because it doesn't know like what label means, and that's like the error is quite descriptive, but also a bit cryptic. But it says like it doesn't know what the keyword argument label means. And if we look over here in this link that I opened from here, in the documentation of this legend item, then we saw that it accepts different parameters, so completely different. But you can set different things also. So you can also say the font should have this size, or it should have a shadow, or it should have a title, and that's exactly what we want. So we don't want a label, but a title at this time. So it's a bit of this having it done once you figure out that there's things that are not always the same. I wonder whether the location parameter works. No, it does not either. So let's remove that one too. But yeah, now the label is a title and it's still over here. Let's maybe skip experimenting with this, but if you feel like it, that's definitely something to explore a bit at home. Like what kind of functionality is possible, what kind of keywords are possible for this legend item. So there's a whole lot of different things. So like whether it's left, right, whether it has 2 columns, whether it is white in the background, whether it's half transparent, or whether it has a different color. But instead, let's do something more interesting, and that is let's add a base map. So in order to have a bit of orientation, to start with that, maybe like a word of warning, and it says here already, all of these tile maps, all of these, or most of these online maps come in this specific projection that's called Web Mercator. It's 3857 is the EPSG code, and typically it's smart to reproject everything else into this tiles projection rather than the opposite way, because yeah, not all libraries support it. This contextually, which we are going to use, actually supports it, but it also smudges all the map a bit. So it's definitely best if we now take our accessibility grid and convert it to this Web Mercator projection, if we keep working with it. And I'm going to do that for all 3 of the layers. And lo and behold, I'm again gonna just copy this code from up here, which we used to plot this travel time, and then add the base map by using this contextually library or package. And we first have to import that, as always. And then once we have this access object, we can add a base map by using this contextually add base map and saying it should be added to AX. Just have to double check whether that's correct. Yes. So it's all the same we had just a moment ago, except that we now imported contextually, and then you call this contextually add a base map. Plus I also didn't print the metro and roads now, but this is taking surprisingly long, but here we are. So there's now like this background map. this one line that adds that. And this background map that's being added by default is like this Stamen terrain design. So it's this Stamen is like a cartography office in the United States who produce different of these background maps that can be used for free. But then in this link underneath, you see that there's a whole lot of different maps that can be used with this library with Contextually. You just have to provide an option to use that. So there's, I don't know, like really a lot of them. So also Strava and also here maps or also Esri maps. And the easiest maybe is this OpenStreetMap, and let's try to use that one. Some of them, like just to add to some of these, need some license key, so you actually have to have a subscription for them and pay for them. But like OpenStreetMap and Stamen, for example, are for free. Let's do the same again, but this time use a different base map. And the way we do this is we add a parameter that's called a source. And let's spread that on multiple lines so it's more readable. No. And this source has to be one of these different map providers that are listed over here. And you can get them, and it's documented over here, like for example, by, like it's in contextly.providers.openstreetmap, for example. And OpenStreetMap here is not a map provider, but it's like a bunch of map providers. So we have to still specify one of these options of it. So let's use the Mapnik, which is the really normal one. Or let's use black and white. Never. I mean, you can use whichever you want. I just wanted to try out the black and white. Okay, and apparently I have a typo in here, or it just doesn't exist. Let's go back to the default. And it's a different background map, but you can't see that so well now because we are so much zoomed out. But it is slightly different than this one, but still very similar. Maybe you could work on a subset of this data and for example, show only, I'm just copying the entire block again. But then I add here like a filter that we want to show only places that are within 15 minutes of the, like where the travel time is, like, and that column was public transport underscore R underscore T, like the one we're using here, where this one is less or equal to 15 minutes. Which should be much smaller map in the end. So it's only really the city center. And Basila and Kuulosaari. And then there's still one more thing we're going to visit here before finally going to interactive maps, which is down here you see that it has this automatically this copyright notice that's required, like contextually is smart enough that it adds these copyright notices when you have to put them. So like these maps are free to use, but you usually have to tell who made them. But now this is not only OpenStreetMap, but there's also our own data, which we got from Digital Geography Lab. So we can just add that one here too by, again, copying this entire block and just making sure I do the right thing. Yeah, and here in the contextually part, we can add another parameter that's called attribution, and it's a string, so it can be, for example, travel time data, copyright Digital Geography Lab, and map data, copyright, what was it, OpenStreetMap contributors, I think was what was in here originally. Yes. And really stick to these things. If you like leave the original part in, don't just kick it out. I mean, it doesn't matter if you make a map for yourself, but if you publish it anywhere. And with this additional parameter attribution, down here it now says that there's 2 different data sources. You can revisit all of this as always on the course page. So it was on static maps, and we also ended up at the same final map here, except that I typed these things a bit more elaborately for the web page. But let's continue for now with the interactive maps. And that's the other notebook. If you just open that one, we're going to use this library called Folium, which does all the magic of handling JavaScript in the background, and Leaflet, which is JavaScript library to display maps in a map, maps in a web page, and we don't need to program JavaScript today, but this library is doing all for us. But the output is still like a web page, and web pages are in HTML hypertext markup language format. So we want to have a place to save them, which is why this is a bit longer than usually this directory place, because I also created here like an output directory to save the web page then. And let's start with the super easy thing of just displaying a map at all. And like I already said, this library is called Folium, so we have to import that, and then we can create a map by creating folium.map. What it needs to create a map is like a location where it should be centered, and I wrote down that 60.2 and 28.8 degrees is Helsinki city center, and it needs to have like a initial zoom value. So, and this zoom value is between 0 and 20, and yeah, 20 is really zoomed in, 0 is the entire world. So you have to bit guess if you don't know, but this one is now like, let's start with 10. This works quite well, I think. And oh yeah, and I forgot, this is a bit more down to earth library, so it doesn't automatically plot the map, but you actually have to like tell Jupyter to show the map by still writing map once here. So that's the variable we created here. And then we have this map of Helsinki is centered on the city center, which we can pan and zoom, and yeah, that's it so far. So we can also, for example, zoom in further already in the beginning. So use 13, for example, and apparently what I chose is not the city center, but it's somewhere in Espoo, niin. Otaniemi. All right, so this course should actually not be taught here, but in Aalto. Or did I make a typo? I really tried to center this on the city center, but yeah, well, it's not. So there's the code again. And I'm going to add one more thing here, which is Folium has again, like its very own syntax, but to add like a scale bar, you would say like you want a control underscore scale and set that to true. And then in the bottom left, there would be a scale bar. Does that work for everybody? Did you get map? Great, perfect. And to save it, we can just again use this map and then save it into like the map which we created here and which we show here. We can just say map.save, and then how did I call this HTML directory, and then say, I don't know, some file name, and it's an HTML file, so it should have the file ending HTM or HTML. And saving that, I don't know now actually how to open it on the notebook, but where did I? Oh, here, like this is the directory we just saved it to. There's now this map.html. I don't know whether it opens inside this Jupyter, but let's see whether it does. Oh yeah, okay, we have to trust it, and then it's a website. So you can also download that file and open it in the browser directly. And again, Folium has a default base map. In this case, it's in here. Like you have to refresh this maybe, like that it shows that there's an HTML file now. Like just this small window here. Do you have it? Yeah, great, perfect. So again, like Folium just takes a default background map, and in this case, it's OpenStreetMap, the really default one. But it also has like this long list of or it's not so long, but it has a list of different maps it supports. Let's try out how to change that. And this session is really a lot of copy and pasting. Again, I'm just stealing from up here what you already typed, and then add here another parameter which is called tiles in that case. And I already know that I want to show this stamen toner one, and maybe also let's go away from Aalto, but also not to Kumpula. But I wanted to show you Brooklyn, which is 40.7 and minus 73. And this stamen toner map is very popular with like people who plot some kind of single color maps on top of it, some statistic complete maps, for example. So what I changed was this one here. But let's maybe go back to Helsinki and create yet another map. And again, I just copy and paste here. And here I now use 25. Okay, let's hope this one now works. And zoom start 12. But what I want to do is add a marker on this map. And we're going to use this volume.marker to add a marker to a volume map. And there's a link on this. I don't know why it's not blue inside the notebook, but it's this marker item, and it has a few parameters you can use. It has a location and a name, like which is then shown in the pop-up. So I'm just gonna go back over here and just type it from my notes. So if this is now, say, Kumpula is a volume marker. And what did we need? We needed to say, tell a location, and this is now embarrassing if this is not true, but it works. It worked before, so 60.204 north and 24.962 east should be Kumpula, and I'm gonna add this tooltip so it shows. And what I still have to do then is like add, like use this Kumpula of this marker, the method add to, and say it should be added to this map. And yes, it worked good. And then there's a marker here on top of Kumpula, and this tooltip thing is that if I hover over it with the mouse, it would say that text that I typed here. In the instructions on the course web page, I still changed the icon also to be green and have like a marker icon in the middle, but you can explore that at home. I'm gonna skip that for today. But let's rather go one step further and use a data source to actually plot something. And we're gonna use this addresses database that we created in one of the other lessons. And that was in the data directory and was called addresses.geopackage. Oh yeah, that one again. So it seems we have to get this one again. And maybe still check the addresses was this data set we had when we did the geocoding of translated the addresses into points. And I'm again copying this, like how to create the map item here as such, and pasting it into the next code cell. And then I'm also adding this addresses layer now here. And unfortunately, that's again a bit confusing because Folium is trying to unify here the terminology of this leaflet library that it's using underneath, and then also combining those GeoPandas and Python. So I can just type it, and you have to follow me a bit and trust me that it works in the end, and then we can unsolve it once it's there. So we first have to create a new layer that uses this addresses geo data frame as a data source, and this layer is supposed to be a Folium features GeoJSON object, and uses addresses as the data source, and then we can, as before, say that the addresses layer should be added to the map and then display the map. So this part here, like this GeoJSON layer, is the leaflet JavaScript terminology. There's a link somewhere here explaining how things actually work. But for now, you have to trust me that this is the way to make this layer, even though I don't have any way to prove it is, except showing that it works. And that's the addresses we had there. I didn't do any pop-up or tooltip now, so we don't see anything moving over the map. But you can still zoom out and zoom in and pan it around. So, okay, this is a long one, so I'm gonna copy and paste the next code cell into Slack. This is to load the population grid dataset that we used before, also from this HSU WFS server. And it's like, yeah, it's this long data set of population data. So the asukkaita are the people in this cell. As before, we don't need all of these columns, and that's also something that we've done before, so I'm just copy and pasting it into Slack if you want to take it from there. So just removing some of the columns or just choosing some of the columns and like renaming this asukkaita into population, so we have a nicer smaller data set. So if we now show it, it's not 100. Okay, no, it doesn't work anymore because I already ran it once, so I have to reload it from here. And then you see there's only a few columns anymore, and they're in English. Let's plot this data set still, and we again have not so much time left. This is another occasion where Folium uses, again, like a bit different terminology than what we've used before. So to plot a thematic polygon map, we're gonna use chloropleats as like colored areas. I don't know what pleat actually is in Greek, but choro is color. So to plot colored polygons, we have to use this choroplete object or class, and it's explained a bit better in the website, so you can read it there. One weird thing about this, or one complicated, frustrating, or hard to understand thing now here is that this choroplete class takes two different data sets. So it takes the geospatial data set and then the thematic data set separately. But in our case, we actually already have put it together. So we're going to supply both data sets or to both inputs, we're going to supply the same geodata frame. But we have to supply it twice, and also we have to have an ID column that's exactly the index. So which is why we have to run this line here now, which is adding another column to our data set called ID. That's exactly the values of the index of the geodata frame. So maybe I can still print that here, so I just added here another column that's ID, and it's exactly the same values as the index in the front. It's just needed to join these. For Folium, we supply two Folium, it looks like we supply two different data sets that have to share an index. And we have to tell it that there's a separate column here. Yeah, so actually let's go there also, and I'm again scrolling a bit up and copy and pasting this code that we already used a few times today, like just this creating this base map. And then let's create this new population grid layer, and this time it's this Folium complete item, and I already said we have to supply both the geospatial dataset, which is our population grid, and the thematic dataset, which is our population grid. It is confusing now, but it's logical in a way. Then we have to say which are the relevant columns in the thematic dataset, and that is we need two columns here. The one is the ID column with which we can join it to the geo dataset, and the other one is the column that contains our data that we want to show in the map, and that's the population in our case. And then we still have to tell for the geospatial dataset that the column to join it to is ID. Or actually, sorry, this is not true. It's feature.id for reasons I'm not going to explain here now, but there has to be this feature in front of it because that's being done in JavaScript, this join. So it has to be in the JavaScript notation or terminology. Now it worked. It's like pressing the tabulator key, and then it shows me which options there are. And I want to still call the same way, the same add to function or method to add this new layer to the map, and then display the map. And I'm carefully scrolling down a bit so you can still see the code up here, but you can already see down here that we have now this population density or population count dataset laid over the base map, and you can zoom in and out. And there's like this fairly crude but still legend up here. Let's improve that one still a bit. I'm going to add first this highlight is true, which is just a bit of eye candy. It just makes the one grid cell where you just hover over a bit more, I don't know, showing out. And I'm also gonna maybe hide the lines in between the routed, the grid cells, so they only show when it's hovered. So by setting the line width, and it's called weight in this library, to 0. And then I'm still gonna change to a different color scheme, and in Folium this is done with like fill color, but it accepts pretty much the same color ranges that we had in all the other libraries. So we can use the reds here, and then it's red instead of blue. Or let's use the yellow, orange, red. Was it like this? I hope. Yes. And one more tiny thing. Let's use more of this, like it's called bins in this case, like more classes. So this map is a bit more diverse. So we have now 1, 2, 3, 4, 5, 6, 7, 8, 9 categories. And then there's a bit more diversity also in the center. So there's one more thing to do, which would be nice. That is to add something that when we hover over here, it would show that, let's say, the population density. So a bit like we have in this example of Kumpola, that it says Kumpola campus. It would be nice that it says, like, in this grid cell, there's, I don't know, 1,000 inhabitants. Again, that's a bit complicated, but or that's not supported out of the box, but there's a really easy way to do it. We just put another times the same layer on top of it, make it transparent, and then add a tooltip to that. And why do we have to do that? Because this co-replete thing, which does these map classifications for us, does not support the tooltip parameter, but the GeoJSON class here, like which we used for the points, it can also display polygons, but it's a bit more difficult to style the different categorizations. So which is why we used the co-replete thing. It can. So let's add another tooltip layer, but yes, let's just do that one after another. So, and like, what did I want to do? Yes, to say it. It's like, again, this GeoJSON type of thing, but of the population grid. And adding that to the map. This is now going to be not transparent as we wanted, so we're going to have to rerun the previous cell again, but just to show you, like, if... no. Okay, I don't know how to type these things anymore. So that would be just adding the layer on top, but it's now covering our thematic layer, so we don't want that. Now there's another complicated thing here, that GeoJSON layers can't be styled directly, but you have to create a function that accepts a feature and returns the appropriate style. So, the good thing is for us here, we can write this style function also ignoring the feature. So we just always return the same thing independent of what our feature does. And this style is a dictionary, and for our purposes, we want to set the color to the transparent, and also the fill color to transparent. And then use this in here. No. say the style function for this layer, for this new layer. No, sorry. Should be this style function we just created. And I have to run this previous cell again, because otherwise we just add new layers on top of things, and we never see them. But if that one now runs again and refreshes, and then we add this tooltip layer another time, you don't see it, but it's on top of here. So there's a transparent layer on top of the other grid cells. What's now still missing is the actual tooltip. And to make it a bit more complicated, because it's not yet complicated enough, let's use yet another tool, which is a Folium class that's called GeoJSON tooltip. And why do we use that? Because it allows us to choose which fields should be displayed here. So if we now say we want to show the population tooltip, and then it allows us another thing. It would allow us to show multiple fields here also. No, hey. And it also allows us to add a label for it, so we can, for example, have a really long description that's being used then in the pop-up. And then that's still something that needs to be added over here. And to summarize, what we did here now is we created a new layer out of the same data set that we have for the thematic layer. We assigned a style function to it that always makes every one of those features transparent, both the fill and the line color, which means it's not shown, but that we also created a tooltip thing that's being shown when hovering over these invisible transparent cells. And those tooltips show the column population with the label population in this grid cell. And I mistyped something. But what did I type here wrongly? I need, sorry. Like it should be like this. I somehow was thinking this is a dictionary, but it isn't. And yes, so now it creates this little pop-up that always shows that here in Hakaniemi 2,380 people live inside this one cell. But in Maunola over here, it's only 472. Pohjois-Haga, there's only 8 people in this cell. Anyway, I realized this is a very, oh, okay, I did that now in the wrong place. So there would have been more explanation underneath, which is also in the webpage. I realized this is a very confusing extra thing here, and that's definitely like one of the lessons that needs to be a bit polished for coming years. But I hope I showed you one way of creating some interactive maps where you can pan around and show pop-ups and things. Down here, there's a few other links to packages, to other packages that do similar things. So for example, this GeoViews can create these kind of like global displays, for example, and then bit interactive like sliders for time series data and stuff like that. Mapbox GL is like a commercial offer, but which is free for if you don't use it too much. Bokeh is like a more general interactive data visualization library, which also has a map support. So for example, this Texas map that we saw in the very first lecture is made with Bokeh, which does a very similar thing that we did today, except a bit more fancy maybe. And Plotly Express, I've never used myself, but it looks very promising. So it does also similar things. So, and there's good documentation apparently. So this is also a very similar thing. Yeah, what's left for today? There's a very, we don't have lesson next week, so you have 2 weeks for, or you have 3 weeks for the next homework, because next week is Independence Day on Tuesday, so we're not meeting. There's still going to be a work session next Friday if you want to come, and the exercise for the next 3 weeks is a bit bigger or a bit less guided. Let's put it like that. It's not bigger necessary. So we want you to create 2 different maps. One static map, which has to have a few, like a thematic maps. You can use whatever you want. There's a few criteria, so it has to have more than 2 data sets involved. So we see that you know how to handle data. And it should not be just displaying the raw data, but it should do something with it, like classifying it in a creative way, or carrying out some kind of analysis. So that's a static map. And then the second problem is very similar, but dynamic, so interactive and showing a bit more, maybe having pop-ups, not using exactly the same example as the static map, please, but a bit varied. You can use whatever data sets we used in the class, or also whatever else you find as open data, and just be creative. The thing is, we're going to give a bit style points there maybe too. So the required output is very little in a way. So it's like one static thematic map and one interactive thematic map. But then how you exactly do it is gonna, I don't know, make us so excited that we give you all the points immediately, even though you did something wrong on the way or not. So you're gonna see. But it's not gonna be difficult. Just create 2 beautiful maps. Take your time. You have 3 weeks and a holiday in between. And I think that's it for today. Thanks.